So here we've set the system up to be ready to start using a single photo gate to perhaps look at some physics activities, which we'll have a look at. Just connected that, just using a standard stereo audio 3.5mm jack cable, readily available, to connect the control unit with the photo gate. We'll just step through now how to set up the device for an activity. So we'll just turn it on. For the moment, we're not running this connected to the computer. We'll have a look at that software side later.
The system is initialized. It will now accept configuration via the computer. If you wish to set up the system using the button interface, press the middle button.
So as we'll see, to set up the timing gates, there's a number of different options which we could choose depending on the kind of experiment that we're doing. And so that means with the menus, we need to go through several steps of menu, which we can all do just using the button interface. It's much quicker if you connect the unit to the computer and just quickly tick a few boxes and download the configuration to the unit. But we don't have to. So it's good just to see how this works separate from the computer. So it's waiting for that computer command at the moment, but we'll just step past that and just use the button interface.
The system can now be configured using the button interface. Please select an operating mode. Press the middle button to select an option. Press either of the side buttons to load that mode. You have selected single gate timing mode.
So that's the one we're after for the moment. So we'll press either of the side buttons to lock that in.
Single gate timing mode is loaded. Press the middle button to select reporting options. Then press either side button to confirm that option.
So at the moment it's asking us to choose from different reporting options. And the reporting options, as you'll hear, could be the system will just speak the data. So it'll do some timings, it'll just speak the data. We can set it up to speak the data and send the data to the computer if it's connected. So we can record that data into a spreadsheet. Or for, I'm not sure why, but if you wanted to just silently send the data to the computer so the students can then analyze it on the computer, you can also configure it not to speak the data. So we'll just step through that and select an option.
Speak the data. Speak the data and also send it to the computer. Send the data to the computer.
We'll go back and choose the first option.
Speak the data.
So we just, for the moment, for this demonstration, just get it to speak the data. So press the side button to lock it in.
The system has been configured to only speak the data. Now press the middle button to select data capture options. Then press either side button to confirm that option.
So it's now asking for what we've termed data capture. So not reporting, but data capture. Because when we're using the single gate, we could capture different kinds of information. So we could just measure the time that the object blocks, the duration of the blocking by an object. So as a ball rolls through, it will block the optical gate, the photo gate, for a period of time, depending on the size of the ball and its speed. So we could measure just the duration of that. If we set this up to perhaps say measure the frequency, the period of a pendulum, then we don't necessarily want the duration information, but we do want the interval. So it's going to block it, unblock, come back and reblock it, and we want to measure the interval between those blockages. So it depends on just what kind of investigation, what kind of experiment you're setting up. And you can set it up to look at the interval between, the duration, or to measure both. It doesn't automatically give you both because that can probably give too much information and make it confusing for the students to remember all of those numbers and to make sense of them. So we'll just step through and we'll just see what those options are.
Measure only the interval between interruptions. Measure only the duration of the interruption. Measure both the interval between interruptions and the duration. Measure only the interval between interruptions.
So perhaps we'll set up and we'll do a pendulum experiment. So for that we want to go and measure the interval. So we would start with the pendulum to the side, it would swing through, it'll come back, and we want to measure that interval. So we'll select interval for this experiment.
The system has been configured to record only intervals, but now press the middle button to select options for how many trials to collect. Then press either side button to confirm that option.
So it's now asking us how many trials, how many sort of runs of the experiment we want to do. So we can choose to record sort of just one event. So if that's, we release the pendulum, it will go click, click, and then it will speak to us the data, the measured interval. If we were having the pendulum swinging backwards and forwards several times, we wouldn't want the system to be trying to speak the timings for all of those intervals all at once. Otherwise, that would just run over each other. It would be very confusing. So we can set the system up to just run kind of one shot, just one event, speak the data, or we can set the system up conveniently to go and measure 10 events, and it'll be silent whilst it's measuring the 10 events, or it won't speak, it'll beep each time. And at the end of 10 events, it will then go and give you the average for the measured interval or the measured duration. So you can set it up as a one shot or 10, or you can set it up to just continue to do that until you press the middle button to get it to stop. So that might be 3 trials, could be 30. It'll keep track of how many trials it's had, average that out, and then give you the result. So let's just set this up.
Record a single event. Record 10 events and average the results. Record until the middle button is pressed.
So that would run in sort of a continuous mode until you choose to end the trials.
Record a single event.
So let's set it up for a single event.
Single event mode is confirmed. The system is ready.
So we've set it up for intervals, we've set it up to speak the data, we've set it up to just measure one event and give us the result, speak the result to us. So for this activity, we're not using the puck, lights are off, the puck's not being used. We would just be using the photo gate. And we can just quickly test that with our hand. So just like a pendulum.
The interval was 1.22 seconds. Press either of the side buttons to run a new trial.
So the way the system is set up at the moment, intervals will be reported back in seconds because typically that will be sort of the duration, the time scale that those sort of intervals will happen on. When the system is set up to measure durations, those durations will be much shorter, and so the system is set up to report that duration back in milliseconds. And the system has a precision, an accuracy of about 10 microseconds. So it's sort of a hundredth of a millisecond. So it's very accurate and very precise. So the timing of the occlusion, the blocking of that, will be reported back in milliseconds. So we've got that set up now to measure intervals. Let's just set up a pendulum and just see what we can discover with that arrangement.
The system is ready.
So here we are. We've got the control unit set up to monitor a single photo gate. We've got it set up to speak the data, and we're going to measure the intervals between interruptions of the photo gate, and we're going to do it one run at a time for this particular demonstration. So I've got a pendulum set up here. It's sort of suspended out of view of the camera. The length of the string is probably 80 centimeters, 70 or 80 centimeters. We could measure that because that's important. When the pendulum is still, it's kind of important to, if we're going to get good measurements, to make sure that the pendulum at the bottom of its swing is kind of lined up kind of exactly with the gate, the center of the gate. More important for some measurements than for others. And now we're sort of ready to go. So I'll just move that out of the way. Now, I would expect in sort of a normal laboratory situation or experimental situation with students that have sort of visual impairment, we would give them a sort of a target point to go and bring the pendulum back to, for a number of reasons. So they can control the amplitude and also the direction of the swing, so that they don't spend all of their time hitting the posts off the gate. So if they sort of bring it back to a control point, it'll be kind of repeatable on there. So let's just see what we get. We'll start another run.
The system is ready. The interval was 0.83 seconds. Press either of the side buttons to run a new trial.
So the measured interval between breaking the beam and moving out and breaking the beam the second time, so we're measuring that period of the pendulum, 0.83 seconds. We'll just try that again. Oh, need to set it up to accept the run.
The system is ready. The interval was 0.83 seconds.
Very consistent.
Press either of the side buttons to run a new trial.
What would happen if we set the experiment, and this would be the questions I'd be asking the students. We moved the starting point further away. We've got a bigger swing, a bigger amplitude, we would say. What's their thinking? And this is always how I would sort of run these investigations. It's going, we've got some data, we've made a change, get them to predict, guess, think about what the effect would be. A bigger swing. Will the period, the interval, be shorter, longer? Get them to think about it.
The system is ready.
Here we go.
The interval was 0.83 seconds.
And that's
Press either of the side buttons to run a new trial.
So that's the same interval, even though it was a much bigger swing. And that's one of the rules of pendulums, one of the laws of pendulums, pendulum motion, that can be discovered using this kind of arrangement.
The system is ready.
So I've moved it even further away.
The interval was 0.83 seconds. Press either of the side buttons to run a new trial.
And that reported number is, again, accurate to a few milliseconds, which is very precise. So we could set an experiment up like this, change the lengths of pendulums, see what effect that has, explore the effect of amplitude on the interval. We can also look at the duration. How quickly is the pendulum moving as it goes through the gate? Does that change, or is that always constant as well? So we can also try with the same pendulum, adding more weight. Might just be a bottle, empty bottle at the start, add some water, add some water, add some water, so we can change the weight. See whether or not mass has an effect on the pendulum. So that data can just be verbalized, and the students can discuss it. They can record it through their traditional means, or it can be recorded onto the computer for them to come back and analyze later if that's something which is desirable and possible within the teaching. So that's kind of one short aspect of a single gate experiment. So here we've got the system set up more or less as before. A single photo gate, optical gate, connected up to the control unit. This time, rather than a pendulum, I've just got a piece of curved wood, some architrave, to serve as a track. Made just a little bit of a ramp up here so we can be kind of consistent with kind of where we start. So I don't need to see what I'm doing. I can feel where the ball is at the end of the ramp. So I've got a good, reliable way of kind of restarting and retrialing. And we'll set the system up now, not to measure interval, but we want to measure the duration. So how long does the ball spend as it's rolling, spend blocking the beam? And this is set up, this is a billiard ball, a snooker ball, it's 50 millimeters, quite accurately. And it's set up so that the photo gate is looking through the broadest part. So when this moves past here, we know that the object that's blocking this is 50 millimeters. And we'll set the system up.
The system can now be configured using the button interface. Please select an operating mode. Press the middle button to select an option. Press either of the side buttons to load that mode.
So we'll set this up for a single gate to speak the data, do a single trial, and we can repeat that, but to measure the duration.
You have selected single gate timing mode.
So we'll confirm that.
Single gate timing mode is loaded. Press the middle button to select reporting options. Then press either side button to confirm that option. Speak the data.
So we want to go with that.
The system has been configured to only speak the data. Now press the middle button to select data capture options. Then press either side button to confirm that option.
So what data do we want? It's not intervals, it's duration.
Measure only the interval between interruptions. Measure only the duration of the interruption.
So that's all we're interested in for this experiment.
The system has been configured to record only the duration of interruptions. Now press the middle button to select options for how many trials to collect. Then press either side button to confirm that option. Record a single event.
So that's what we'll go with.
Single event mode is confirmed. The system is ready.
So you may also see the board that I've mounted this to. I've put notches in at every 50 millimeters. So the students can, if they want, reposition this gate, or when they've got two gates, work out the relative positions of the gates, move those around, conduct more trials, and understand what the relationships are then between what they're studying. At the moment, this ramp is flat, it's horizontal, reasonably horizontal. Just a little, very gentle slope. We should try and trim that out. And as I said, we've got the ramp here. I'll put the ball at the top and let go.
The duration was 83.38 milliseconds.
So
Press
83.
either of the side buttons to run a new trial.
So 83 milliseconds. We'll try another.
The system is ready. The duration was 77.57 milliseconds. Press either of the side buttons to run a new trial.
So it's not quite as consistent as when we were using the pendulum. Exactly where I'm starting it, there's going to be those variations, which is important to understand in an experiment. Also, the ball will be rattling around. It will roll very slightly differently. But we can look at that timing of around 80 milliseconds. So we've got a ball which is 50 millimeters wide, and it moved through the gate, and it took 80 milliseconds to do that. So we can use that distance, 50 millimeters, and that time, 80 milliseconds, and work out what the speed of the ball was. So speed is distance over time, and so we can work out the speed of the ball once we've taken those measurements. We could have set the system up to take 10 measurements and average them. That might be a good thing to do. So we're somewhere around 80 milliseconds, 75, 83. I'm going to average that to around 80. What we could do then, again, is let's just move the photo gate a bit further down the track. Would that make a difference? So again, I can sort of feel I'm going to add 100, 150, 200 millimeters further along the track. Is that still within view? Not quite. We'll move it back in view. It's just down there. And we'll see whether or not the duration of the interruption has changed. That will tell us if the speed is changing as it's rolling down.
The system is ready. The duration was 78.10 milliseconds. Press either of the side buttons to run a new trial. The system is ready.
So we could try that again. So it's very much the same sort of time. Is it exactly the same? I don't know. Maybe we should run 10 trials and average those out. Maybe it's very slightly slower. Maybe it's just the same.
The duration was 75.30 milliseconds. Press either of the side buttons to run a new trial.
And so we can do lots of different experiments here. We could try different size balls, different weight balls. We can, of course, then put the track on a slope as a ramp and see what the effect of that is. Changing the angle, how does that change the speed? And all of that's just with the single photo gate. Once we set it up with 2 photo gates, we can get extra information, obviously, from each trial. So with 2 photo gates, we can measure the speed of the ball through each gate and also the interval between the gates. And so we can start to explore these ideas of kind of more or less instantaneous velocity and how that changes, and acceleration. And all of that's possible through a largely independent exploration by the students once the system has been set up and configured for them. And we'll have a quick look at a dual gate setup in sort of the next video clip. The arrangement here could, if you wanted, be mounted vertically and arranged so that you could actually drop and just use free fall for the objects as you're going through. So this could be mounted vertically on a wall. We don't need the track under those circumstances, but you'd need some guide as to where to release the balls and measure them as being dropped from different heights, what the impact is on the speed. And all of this could be done through a largely tactile and audio feedback process. That's the idea in any case.